Hello, everybody. Thank you for joining us for this webinar today organized by Elum Energy and Tesvolt. We are still waiting for some attendees, so we will be starting the webinar in a few minutes. Okay, so thank you everybody for joining this webinar today. We will start now, and if some more participants come, they can join after. So this webinar is organized by Elum Energy and Tesvolt and focuses on solar and storage system for smart charging of electric vehicles. Today, the speakers will be Ayman Benassim, Area Manager of France and Benelux at Tessvolt. Tessvolt, who specializes in commercial and industrial energy storage systems. And the second speaker will be me, Lucas Lecomte, Sales Manager in Europe at Elum Energy. Elum Energy that specializes in monitoring and control solutions for solar and hybrid systems. So today we will have the webinar organized in 3 different parts. The first one will be focused on Elum Energy presentation with our different business units and how we can provide solutions for solar and VSS systems, but also some solutions for smart. And so then we will be focusing on Tessvolt presentation. Ayman will be presenting us the different solutions of Tessvolt to answer this need in smart electric vehicle charging. And in the end, we will be having a question and answer session so that we can answer the different questions you might have on this topic. So if you have any questions during our presentation, it can be mine or Ayman's one, feel free to ask them directly in the chat, and then we'll be answering it in the end of the presentation on live. So now let's start with the first presentation of Elum Energy. And so we'll be addressing this topic of how controlling solar and storage system to enhance smart electric vehicle charging. You should all be able to see my screen, and here is the agenda for this first presentation. So we'll start with a brief presentation of Elum Energy for those who don't know Elum Energy or all of our business units. Then we'll be focusing on the presentation of PV hybrid system, presenting you 2 different system architecture that we will talk about today for smart charging. And so we'll compare a system without batteries and a system with batteries so that we can highlight the limits of the first one, and then expose some new levers of optimization thanks to the battery on the second one. Then I'll present you some of Elum products that can answer this need for smart charging. And last, we'll be presenting different references and partnership with Tessvolt. So talk about a few projects that have been commissioned last year and that maybe will be commissioned also in the next years. So first, company overview. Elum Energy is specialized in energy systems monitoring and control. So for solar and hybrid power plants. We're based in Paris, but we also have offices in Casablanca and Cape Town, so in Morocco and South Africa. And we're also looking forward to open some new offices this year in 2021 in some new regions, so that we can have some sales manager installed locally to manage new regions. Indeed, we work almost in all over the world with projects being commissioned already on more than 40 different countries with more than 100 sites being installed, both for data logging or for control operated by Elum Energy. And still a lot of new projects to be commissioned in 2021. So we work with power power systems manufacturer with EPCs and project developer. Here you have a list of different partners of Elum Energy listed. We have 3 different business units, power plants, telecom, and industry. The one we'll be focusing on today is the one of power plants. Indeed, Elum Energy has some monitoring and control solutions for power plants, from the little residential systems of a few kilowatts until system of the multi-megawatt scale. But still today we'll be focusing on a very CNI application for PV BSS system with electric vehicle charging stations. But just for you to know, we also have some monitoring systems for the telecom industry and for portfolio management. And we also have some sub-metering solutions for industries. What allows Elum to work on those different business units and work on so much different projects and so much different geographies, because Elum products are cross-compatible with almost all the inverters and systems of the market. So of course we're compatible with Tessvolt and those different brands stated here. But if you want to know more about our compatibility in terms of communication for control, you can still ask our sales manager and contact Elum directly by email. So now let's move on to the kind of the heart of the presentation, which is the presentation of those 2 different architectures that we'll be addressing today. So those are the 2 systems we have chosen to talk about today. That are presented here. Both are grid connected. So today we'll be addressing questions and challenges related to grid-tied applications. So we will not be talking about off-grid or grid failure or that kind of issue that are already addressed in some other webinars, but only about grid-tied solutions. Grid-tied solutions for systems that can be either, as you can see on the left, systems with photovoltaic, so solar production, and electric vehicle charging station as conception, but also on the other hand, systems with the same architecture, but in addition to this, having energy system as a buffer, but that is actually not only a buffer for PV penetration maximization, but actually allows us to implement so much broader range of control features and application to make a smarter use of electric vehicle charging. Both of these systems are, of course, in self-consumption, or at least that is what will be considered today. So now let's focus on this first one. So for example, here we could have, for example, a supermarket, a CNI building. Actually, it can be also a factory. This building having its main load related to its activity that has chosen to install some PV panels and PV inverters to produce solar energy so as to feed their load. But they also have chosen to install electric vehicle charging station that can be either for the final users, for example, if we're talking about supermarket, or it can be also some of the parking lots of the employees that can be equipped with such equipment. When installing such a system, there are different challenges. First one are mainly related to the very transformer station and the fact that we will not be able to maybe feed the electric vehicle charging station at full power at any time, because we have this maximum power feeding from the grid. So there is this absolute need of managing the load. So those controllable loads that are the electric vehicle charging station, so as to ensure that we're not having this load booming with this new installation. So it's very important to manage dynamically those electric vehicle charging station. First, because of this very technical question that is the transformer station and the maximum power capacity. but also because of some more financial aspects, because indeed there is also the question of billing of the peak consumption, that we would like not having this peak consumption booming because of electric vehicles. So some client, of course, will try to correlate the consumption of electric vehicles to the power supplied by PV inverters. So there are both some technical aspects and also some financial aspects. And the reason why all those are some real challenges, because changing a transformer station, installing a new one with bigger capacity, it is much longer than installing electric vehicle charging station and solar panels, and it is also very costly. So this is why on such systems, there is a need of installing a controller so as to control both the production and the load. So let's go deeper into the details and see how our system will be installed in such an architecture. Elum products are composed always of this main brick installed directly on site in this electrical cabinet. That is the ePowerControl. This ePowerControl is the main computing unit pre-embedding the Elum Energy algorithm, the EMS, and it is physically installed on site and connected to all the different units to be monitored and controlled. So it will be connected to the grid meter so as to monitor the grid feeding, but also to the PV inverters so as to ensure that we can monitor the power production and also be able to curtail it if needed, not to have some power being fed back to the grid. We are also connected to the electric vehicle charging station, of course, so that we are able to monitor their status, if there is a car, or if there is not a car, but if there is 1, 2, or 3 different charging units connected at a certain moment, so as to dispatch the available kind of maximum power that can be drawn from the grid between the different units. We are also connected to other loads if needed, such as air conditioning, lighting, and others. But we'll not be addressing those questions, not to complicate this example too much. So we really have this component connected through RS485 or Ethernet to all of the different units so that we can communicate over Modbus, and so that we can really have this monitoring and control over all the different sites with a strong reliability. And then we have this unit connected to our cloud services and to our own monitoring platform, or it can also be interfacing with some third-party platform. So it's very important to understand that we have this main bridge, this main component installed on site, directly connected to all of the units to be controlled and monitored, and we have also this additional cloud services. So in such a system, what are the features and what can be done by Elum? Elum will be, in such a case, managing the maximum power production from solar, so as to ensure that we have zero export, and to manage the grid feeding, so as not to have grid penalties because we're feeding back energy to the grid. But there is also this question of smart charging. So thanks to this brick installed on site and that knows how much consumption we have, how much production we have at any time, we are able to manage the available power on each of the electric vehicle charging station so as to allow the charging of cars, even on a slow mode or on a fast mode, that is like directly correlated to the consumption, because if we are in fast charging mode, we'll be consuming a lot, and if we are in slow charging, of course, we'll be consuming less. So we'll be able to curtail this maximum power available on the electric vehicle charging station so as to ensure that we're not above the maximum grid feeding power available, and also to make sure that we are not consuming more so as to not to boom the bill. Then, what are the direct consequences of such system architecture and when operated like this? The problem is that when we're in such a situation where we are trying to manage our bills, electricity bills, but we're also trying to manage the grid feeding, we can end up curtailing the electric vehicle charging station, and this can affect the electric vehicle charging time. So it can affect the end user. And with such an architecture, this can be the number one limit. That is actually a limit that can be overcome overcame with for example, some BSS energy buffer. And so this is why now we'll be moving to the second system architecture that we want to talk about. That is a system of PV and BSS with electrical vehicle charging station. So again, we'll be kind of with the same study case. It can still be a CNI building, for example, a little factory or a supermarket. But in addition to the different power production and consumption units stated before, we will also have these batteries. And so by managing on real time the SOC of the battery, so the charging and the discharging of the battery, we can either move the consumption to other hours, so make some load shifting, so increase the consumption at a certain time so as to reduce it later, or we can also just move the energy produced by PV directly to the battery instead of curtailing. So a lot of different possibilities are new with this system of BSS. So again, the architecture will be the same with this main component ePowerControl connected to all of the different units so as to ensure a reliable control directly on site. But in addition to before, we'll be connecting to the BSS, so the battery inverters, and still connected to all of the other ones. But what can we do more when we have this battery system installed? The real perk of having this battery system installed is that we will be able to store energy to the battery when the grid consumption is low, so that later when, for example, we are at peak consumption hours, instead of even consuming more from the grid because we have those new electric vehicle charging stations, we will be able to feed the electrical vehicle charging station directly thanks to the energy stored in the battery. So this is really important because this helps the client not to have this kind of peak or boom from the electric vehicle charging thanks to the battery and thanks to the anticipation of this consumption. Because on the first architecture that we studied, if we want not to affect too much the consumption on site, the electrical consumption, we have to correlate PV and charging. But in the end, the final client is not always interested in charging his vehicle when there is some PV power available. And thanks to the battery, we can actually decorrelate consumption and production so that we can store some energy in the battery so as to consume it later. This is load shifting, and this helps really implementing some much more interesting strategy because taking into account not only the live and current power being produced or that could be produced and that can be consumed, but being like trying to think in terms of energy over a day. So for example, if I know that I need a certain amount of energy, I can store energy before consume it later. So this is very important so that we can have the most efficient system for the final user and you make the best use of the electric vehicle charging station so that the mini grid can really meet the final user expectations and we can make some much more complex grid feeding management. So if we have to sum up, what are the different added values of storage system in such architecture? First one is charging time, because if we have to deal with all those financial and technical constraints, we will be ending up curtailing or affecting the charging time in the end of electric vehicles. But if we have battery, thanks to load shifting, we are able to overcome those challenges and make sure that energy is available when we need it and when the final user needs it to make some fast charging. Of course, it helps increasing solar capacity and solar penetration thanks to this energy storage buffer, of course. It also affects, in the end, the electricity bill, and it helps optimizing the payback period. So these are the main points and kind of the important things to keep in mind. And I know that Amen will be coming back to those different subjects in this presentation after. So now let's move on to the different products of Elum associated to those architecture mentioned and also to our references. So Elum has a lot of different standard products dedicated to each application. So this is something very important because it helps having those tailored solution for each application so that you can have some standard commissioning, have some technicians being really autonomous on site, installing our solutions. And so for the architectures mentioned before, we have those two products. The first one is the ZE ePowerControl Zero Export. So making the grid feeding management for the creation of PV and electric vehicle charging station. So actually it's the Zero Export plus charging smart charging feature. And we have the ePowerControl MC microgrid controller. That is a system able to manage batteries at the same time as controllable loads and, of course, electric vehicle charging station. Depending on the size of the project, we can have different hardware. So this is why we have the ePowerControl MCS and M. All of our products have this integrated autonomous commissioning interface, allowing all the clients to make some easy commissioning with some almost plug and play systems. So for example, here we have different pictures and screenshots of this interface. So you have some live monitoring being available directly on the controller that is on site. So without the need of internet, if you need to do any troubleshooting on site, you directly have those info. It helps you having some information about status of communication with different devices, about how systems are working right now. It helps you commissioning the system autonomously by proceeding to the network configuration and communication tests autonomously. So for example, here it was a project with Keba charging station and Gudu inverters. And we can see that the client could autonomously configure all that. And then we have, of course, our system available remotely, that is ePower Monitor. That is our remote monitoring and control platform. So here you have a few different screenshots again of this system that allows the monitoring of all of your sites on this one and single platform available directly from your browser, with some different graphs and KPIs available. So for example, this is the microgrid demo for electric vehicle charging station and PV. We can also make some different visuals for maybe broad public communication. Of course, you have different graphs, different kind of widget, and the system of alarms, so as to ensure that you are notified when something is going wrong on site, so that you can react fast. So now I'll be finishing with our references. So this is one of our most relevant references on this use case of electric vehicle charging station and PV, because this is exactly what has been installed at this supermarket in Guadeloupe with one of our partners. We have some good inverters and 2 charging stations of Keba. And of this system, we only have PV and electric vehicle charging station, and we are managing the whole system so as to manage the grid feeding live and to meet our client expectations, so the EPC and project developer, and also to ensure that we have the electric vehicles connected to the charging station charged as fast as possible on site. But again, we have this limit because no battery on site. Still, it's working fine. It's been now many months it has been commissioned yet, and we're very happy with this this reference. We also have this different reference here that is related to BSS much more, because this is kind of the same architecture than before, but with energy storage system. So here we really have the second architecture being deployed. Actually, it will be deployed in the beginning of the year. Most of the communication and the installation have been done already. The system is on monitoring only so far, but we'll be deploying the EMS the beginning of the year. And again, we're very happy to have this project with charging station, PV, and storage in France. Here we have other references in France and French dom-tom as well, with Guadeloupe and Mayotte. And the second project of Mayotte are quite different because it's some PV, BSS, and electric vehicle charging stations that are actually working autonomously. So it's decorrelated from the main load, and it's kind of PV, BSS, and electric vehicle charging station working on standalone. The batteries on this system has been provided by Tessvolt, so it's nice to mention. It's 2 different sites that are almost similar with some similar capacity. One is a little bigger than the other one, and so it's 2 references with Tessvolt and Elum. We also have here some other application of PV and battery in France for some load shifting. And there is this last reference that I wanted to mention that is about PV and BSS management on an off-grid site that we worked on with Tessvolt. And that is not exactly in the subject of today because it's not about charging station, but I'll be just mentioning it quite briefly because it's a system that has been commissioned in 2020, almost fully done by the client autonomously on site with remote assistance. And we're very happy to highlight this reference because it shows that even with COVID restrictions and those kind of difficult times, we are able to commission easily some systems remotely, even if we cannot go on site to commission those systems. And it's a system implementing an Elum controller, but also a storage system from Tessvolt. And the client is quite happy with this system. He's very happy actually because he even made a new order to Tessvolt. So he will be multiplicating the total battery storage by 2 soon. So to increase even more the PV penetration in the time when the system, this off-grid system, is working only on PV and battery. So thank you for your attention. This is the end of my presentation, but we will now be moving on to the second presentation made by Eamon for Tessvolt.
So do you hear me? I hope that everything is well. Thank you, Luca, for your presentation. So first of all, I would like to ask the participants to ask their questions in our question box on the go to meeting. So I will start with my presentation. How controlling solar and storage systems enhancing smart EV charging. So how can I put it away? Just yes, yeah. All right. So I will start with presenting Tessvolt, the company, our products briefly, and then I will go directly to the applications, and then I will go deeper in the EV charging applications, and I will mention the advantages with some use cases, and at the end I will present some references. So, first of all, as you can see, Tessvolt is active worldwide. We have actually Tessvolt Brazil, we have Tessvolt US, we have Tessvolt Australia, and we have Tessvolt in Germany. And we constructed the first gigafactory in Europe. It's in Germany. As you can see, this is the picture of our gigafactory in Germany. This is a picture inside our gigafactory so that you can see the productions of our battery modules. And this is to give you an idea about the growth of our company. As you can see, we started in 2014 with 3 employees. Actually, we are more than 100 employees. So we are doubling our turnover and our also number of employees. We have our gigafactory in Ludwigsstadt, Wittenberg, and we have offices in Berlin and also near Frankfurt. So now regarding our partners, so we are dealing for the lithium cells with Samsung SDI, and for the battery inverter with our premium partner SMA. So and the added value of Tessvolt is producing battery modules and offering energy storage systems, including our BMS. So the battery management system of Tessvolt is a patent of Tessvolt, and thanks to this BMS, we are getting the highest performances in the market. I will go later to those details. So this is an idea about some awards won by Tessvolt. For example, last year we won the prize of Top Innovator of the Year in Germany, with other awards from the Intersolar or Deutsche Gründerpreis as one of the most successful business startups in the recent years in Germany, etc. So this is a very important slide. It introduces the unique selling points of Tessvolt. As you can see, the lifetime of Tessvolt is up to 30 years. We have 100% DoD. Our systems could provide up to 8,000 cycles. We have 1 C as a C rate, and we can guarantee up to 6,500 cycles with 100% DoD as the highest number of cycles under warranty in the market. So you can expand also your system even years later, which is also unique. And we are using the lithium NMC technology with the prismatic also technology, and we have also very high safety standards. The system design of Tessvolt. We are using the Samsung SDI cells. We are putting 14 cells in one battery module to get 4.8 kilowatt hour, and we are implementing our BMS here in front of each battery module. And then, as you can see, all the BMS are communicating with each other, and this is the master of BMS. So I'm just showing briefly the system design to go later to the applications and to the EV charging part. So this is the BMS. You can see here we have our BMS in front of each battery module. We can get an efficiency up to 92%. And we have a Batmon when you can see or visualize each cell in each battery module in real time. So I will go show it later in the coming slides. just to understand the advantage of our BMS. So in the market, there are 3 BMS types: the passive one, the unidirectional, and the active battery optimizer. So we are using the active battery optimizer, which is Tessvolt patent. And thanks to it, we are getting 92% of efficiency and 5 ampere of balancing current. It's 100 times faster than the passive balancing. So, but in the market, we have almost 70 to 80% of the products with the passive BMS. So that's why, thanks to this BMS, we are getting the highest performances with the highest number of cycles under warranty, and also other advantages like we are guaranteeing the cycles up to 45 degrees, etc. So through our Batmon, so the software of monitoring, you can see the complete battery charging and discharging and states. And then we can visualize the state of each cell in each battery module in real time. So we can visualize the state of charge, state of health, temperature, and also voltage. So an idea about our range of products: we have low voltage products, 48 volt, using the SMA Sunny Island battery inverter, and we have also the TSHV70 system. It's including the SMA battery inverter STPS60, which is a high voltage system. And we have the system TSHV70 outdoor, which is the same system as this one, but with an outdoor cabinet. Here we are putting the battery inverter, and here we are putting the air conditioning system. So this is suitable for outdoor application. This is a new product of Tessvolt, suitable for high power off-grid and for backup. It's called IHV80, and this is the system TPS. It's for the megawatt hour scale. Oh, with the TS48 volt, we can go up to 3,000 kilowatt hour. With the TSHV70, we can go up to 6 megawatt hour. And this is the TSIHV80, the new product, as you can see, that will be available starting from week 5 this year. So the advantage of this product is we have a new battery inverter, which is grid forming with a high power. So it's starting from 75 kilowatts. So we can have in just one unit, so one cabinet, up to 300 kilowatts. So we can put 75 kilowatts in each. So each module of battery inverter has a power of up to 85 kilowatts and 87 kVA. So now I will go to the applications. So the applications of the energy systems, the self-consumption optimization, the peak shaving, there is a physical peak shaving, and also the dynamic peak shaving, RLM. We have the time of use, backup application, power quality, off-grid, and charging stations, which I will go deeply in this presentation. Forecast-based battery charging, as Luca was explaining, load control, and generation control. So those are other applications for the grid: feed-in management, ancillary services, mass storage system, and blockchain technology. So now I will go to our product suitable to the EV charging. So this product is HV70 outdoor. As you can see, it's suitable to the EV charging. So this is the system configuration of the TSHV70 outdoor: the battery inverters, the energy sources, PV, wind, and the battery inverters. And this is the EMS side, so the energy management system side. This is the system design, including the EV charger. As you can see, we have the EV charger, and we have the SMA energy meter. We have our batteries. We have a data manager via the InexOS for the visualization of the system, and we have the Janitza energy meter connected to the grid. So I go further, and if there is like a special AMS requirements from the customers, Elum is here the right contact person to help you in your project. So, just to give you an idea about the common charging powers. So we have the Chuku charging power, we have the Type 1, we have the Type 2, and those charging power, they are AC. And we have the Shadimu and the CCS types, and they are in DC. Actually, the most common charging powers, they are the Type 1 and Type 2. So 7.4 kilowatts and up to 44 kilowatts. But actually, for example, Tesla cars or the Porsche Taycan, they could use even those chargers, so up to 200 kilowatts and up to 350 kilowatts. As you can see here, so there is e-bikes, and here there are e-motors. So they are compatible with the Shuku charging power. So I will go further. What is the advantage of adding a battery in an EV charging system? So the grid connection is too small. Generally, the power of electricity is limited. So when we want to add several charging points, and also when we want to add a high power EV charger, so it's not possible when we have a grid limitation. I will explain in the next slides with more details. And also, the grid cannot be expanded. So the footprint locations do not allow the grid expansion. The grid can only be expanded in several years. Sometimes that could be up to 4 to 5 years to expand the grid. It depends where. And there is also a lot of costs of expanding from the grid and other electricity tariffs, taxes, and also the peak shaving. So I will explain it with a concrete use case. So here, for example, this is a general use case. For example, architectural firm with 10 employees. We have here a limitation from the grid with 30 kilowatts. Okay, and the customer would like to install an EV charging station with 2 charging stations with 11 kilowatt of power and 1 high performance charger with 50 kilowatts. But as you can see, the building connection is very limited. So in that case, we don't need to expand from the grid, which is expensive and could take almost 2 years, for example. So you can just install batteries, connect to the grid, or even you can add the PV, and then you can have an extension from your power. So if, for example, if we install here a system with 120 kilowatt and 130 kilowatt hour of batteries, so we will not have a problem even with those 3 or even 4 EV charger. So another example, small offices, architects, consulting firms, advisors, or medical practices. Generally, they have 30 to 40 kilowatts of grid connections. So, and here it's very limited. So if the employees or customers, they want to add 3 to 4 charging points with 11 to 22 kilowatts and 1 high performance charger over 50 kilowatts. As you can see, there is a limitation from the grid. And there is also, if you want to expand from the grid, there is other electricity tariffs and involvement in grid expansion, etc. And also, there is a peak loads, high costs if we want to expand the power from the grid. So that's why when we are implementing the Tessvolt system with a battery inverter, batteries, and EMS, so we can save a lot of monies instead of expanding from the grid. But this is also a common use case. Supermarket with a sales area around 1,200 square meter. So just for your information, generally the supermarkets, they are limited with the power. For example, this supermarket has a peak of 90 kilowatts. So the grid company will provide the customer 95 or 100 kilowatts of power maximum, which is really very limited. And if the supermarket wants to add some charging points for its customers, it will not be possible with this 100 kilowatts. So that's why generally the supermarkets, they are adding 3, 4, or 5 charging stations. They add batteries so that they avoid the cost of extension from the grid and the other costs. This is also another use case in the parking in the car parks, as you can see. Lately, there is a new law in Germany, and that will be also valid in Europe. Each new car park should has 10%. So 10% of parking space will have charging station from 2021. It means if we have a place for 1,000 parking place, we need 10 EV charger. So that's why that will really push the EV charging business with batteries. It's cheaper than extending from the grid, plus the time to wait this extension, etc. So in that case, we add batteries and EV chargers. This is also another use case. Car hire service with electrical vehicles. Generally, we have 30 to 5 kilowatt of grid power. And as you know, for higher services like Sixt, for example, rent, they need to give their customers a car very fast. So that's why they need a high performance charger over 50 kilowatt, and even over 100 kilowatt is better. But with this limitation, that's not possible. So that's why they need to add batteries and EV chargers to their sites. So that's why it's much it's economical to add batteries than extending from the grid. This is also another use case. For example, for the industrial and commercial enterprises, usually they have more than 1 megawatt of power from the grid, but it's still not enough if we want to add 100 to if we want to add 10 to 100 charging stations or charging points, because as you know, the employees, they came all together maybe at 8 or 8:30, so they have to install a lot of charging points, and the power of the grid is still not enough. So that's why they have to extend their EV chargers with support from the batteries. So that's why we can save a lot of monies and time. So just to give you an idea about our references, as an idea what we have installed with Tessvolt for the EV charging. So Tessvolt was part of the Europe's largest e-car charging stations. It's in Germany. It's Charging Park Hilden, and there we used 2 megawatt hour of batteries and 2 megawatts of battery inverter. As you can see here, we have the super charger of Tesla. You have PV, but the customer chose the Tessvolt batteries thanks to our performances. This is also another reference. It's in Finland with 134 kilowatt hour of batteries and 120 kilowatt of battery inverter for the peak shaving, as I was explaining. You can see here the batteries, and here we have the EV charger. And as a last reference, this is a reference in Germany with 67 kilowatt hour and 60 kilowatts. So I hope that I explained the use case very well. And if you have questions, please just ask them. So.
Thank you very much, Ayman. I see that we had a lot of different questions sent in the chat. So I prepared some of them. So I mean, you can have a look at them if you want to pick one. And while you have a look at the chat, I can already maybe answer one or two that were addressed to Elum.
Yeah.
So from the question that were mentioned, I've seen some question regarding the communication between the Elum controller and the electric vehicle charging station. So we do control them over Modbus. I've been questioned about OCPP. OCPP has not been developed so far at Elum Energy. So for the moment, we're controlling them over Modbus. And the control is operated by the ePowerControl that is directly on site. So the control loop is from a site, from an equipment installed on site, the ePowerControl, to another one that is physically wired to it, that is the electric vehicle charging station. Also some question with regards to V2G management. So being able not only to charge batteries, but to use the batteries of the electric vehicles as a source of energy to feed the main load. So the main building can be a supermarket, factory, or any. Indeed, Elum has already been working in some pilot projects integrating V2G chargers. So it's very important that the charger itself and the car are compatible with such technology. And if yes, of course, Elum can integrate those systems to implement some custom strategy according to your need and discuss yes about this integration. But we already have a pilot site in France about this. So yeah, indeed, that's another subject that is coming more and more. Maybe Ayman, you want to pick a question that was addressed to Tessvolt?
Yeah, so here, for example, I have the question of Daniel. So I want to know more about your storage battery. So just contact me via my emails so I can go deeper with our energy storage systems, details, system designs, applications, etc. I have another question from Batu Varlik. So you mentioned 6,500 cycles. How long can we consider this value in terms of time? So it depends. If you have one cycle per day, so that could take up to 20 years of lifetime. If you have 2 cycles or 3 cycles per day, that will be up to 10 years maximum. So it depends on the applications. But generally, for the increase of self-consumption projects, or even for off-grid applications, so that could go up to 17 to 22 years. So I will see the other questions. This is a question from Samson. Does Tessvolt have any office in South Africa or Nigeria, considering that these are the largest economies in Africa? So we don't have an office in South Africa, but we have a strong partner of Tessvolt in South Africa, which is SolarWorld. So you can get in touch with them. So they are certified from Tessvolt, and they install with us, I don't know, maybe more than 200 systems with Tessvolt, not only in South Africa, but even in other African countries. So
I see also many questions related to off-grid application that we did not mention today or very briefly. So indeed, there are also some systems with some electric vehicle charging stations, some battery storage system, and some PV working on standalone as a unit really dedicated only to electric vehicle charging. If you want to know more about those things, maybe it's better if you send email to us directly to the teams of Elum and Tessvolt. But of course, we can also address that kind of site and have solutions, as we have one that is currently installed in Mayotte with Tessvolt and Elum.
I have, yeah.
Yes, I mean, if you want to pick one, I have one for after.
Okay.
I think we can maybe answer one last question for you and one last for me, because it's almost time.
Yeah, okay. So here I have seen the questions about from some participants about the type 1 and type 2 of the charging power. So this is not in our scope of supply. So that's why I cannot give you a price about it. So our scope of supply is the battery inverter, the EMS, the BMS, and the EV charger should be purchased from another supplier. Yeah, you can go, Luca.
Yes, sure. I have an interesting question here also that was asked in the chat. So, can Elum control management system receive orders from another application in terms of charge and discharge? Indeed, Elum system can interface with some third-party system. For example, we have a system that was installed in Guadeloupe, where we are operating the electric vehicle charging station with our own strategy and etc. But in addition to this, we have some commands sent by the EDF SEI API. So online, we are getting a specific status, and it asks us either to charge, discharge the battery of the electric vehicle, or to keep the system on standby. So indeed, we can interface with APIs or with third-party system, but this will be custom and needs to be discussed so as to agree on a specific technical specification for a product, because indeed Elum has some engineering team dedicated to custom project or custom integration. So we are also able to develop custom EMS for some given project. I think it's time. I see that it's 2 already. Unless you have one final question or comment, Amen.
So I have seen that there are a lot of questions, but unfortunately we cannot answer all those questions in this short time. So I would prefer that the participants send us, they have to feel free to send us an email to ask all those questions, and we will be more than pleased to answer all those questions.
Exactly, yes. Thank you very much for attending this webinar today, all by Elum Energy and Tessvolt. And of course, if you have additional questions, feel free to contact us directly by email. We'll be answering your question. It can be those that you have already asked, but also some new questions. And for all the people asking about the support of the presentation, of course, it will be sent to you by email later by our marketing teams. So thank you very much, everybody, for attending this meeting, and have a nice day.
Thank you very much. Have a nice day.